Hello, welcome to the channel. So we've got another Paul Reed Smith amp. This is a combo this time, and this is a Sonzera 50, suffering from double divergence, which is anybody who watches my channel regularly will know that that is dry joints, or that's what's suspected anyway. So we're going to have a look at this amp, just see if we can find out what is wrong with it. Sure we can. Not seen one of these before. Couple of channels, got presence control here, the pilot light. We've got reverb, bass, mid, treble, master and volume channel select, and then this channel's got reverb, bass, mid, treb, level and drive with a bright switch. All the gizmos. Don't know much about this amp at all. Not seen one before. Looks like a relatively new one. Let's have a look at the back. Right, we're looking at the back, and we've got separate sockets for each impedance for the speaker. So we've got 4 ohms extension, 8 ohms extension and 16 ohms. So that goes down to 2 ohms then, according to that. Strange. Foot switch bias here, so you can do the bias on the back. There you've got common bias, and then you've got the adjuster. We've got one for each side. You've got the adjuster. So common bias for one side of the transformer, common bias for the other. Send and return, on off switch, standby switch, HT fuse, power fuses in the IEC. And you can just see pinks appear. It's not been in a video for a while. So let's get the back off and have a look. So I've got this amp plugged in, and when you turn up the master, I wonder if that's a 2. But then if I plug this, if I go to this side, so yeah, I've got it on this side as well. That's not good, is it? That is. I wonder if that's a tube that's causing that. Let's have a look. Heater to cathode short. Don't know. Right, we're going to look inside, and it looks to me like somebody's been chasing a fault, because there's flux all over those all over those tube sockets. And this again, I'm just going to use a pointer because I don't know if these caps are discharged. Again, look at all this. I mean, this is just not necessary. It's just everywhere. There, it looks like Pink's ooey greened in it. It does. All around these things, it's just, there's just no need for that. What's this? Is this got a resistor here, chassis mounted resistor. Let's see if, I bet there'll not be a schematic for it, because there wasn't for the other one. Not a trace of one, and I don't see there will be for this one either. Can't see that. Yes, somebody has been chasing this fault, I think, because if we look in here, there's a bit of a clue. Remember, we've got a hum, and look how scratched it is here. See how that's all been scratched there, as if somebody's been, and they've obviously not found it, and it's landed up on my bench, as they always seem to do. And let's just hope I can find it. So let's just have a look at the build of this amp then. So it looks like we've got the Fender Blues Junior caps in there, or that they have in some of the Fenders anyway. They certainly have those in the Blues Juniors. It's solid enough inside when you know, everything's solid, but boards are a little bit thin on this one. Let's hope it's a case of boards don't hit back. Otherwise this fault may take a lot of finding. So I don't know how much these amps are new, and I presume this is a current model. Well, I think the first thing to go for is the tubes, see if that's a heater to cathode short or leakage or whatever. We could pull the tubes and drop them in the tester, but often with preamp tubes I think you're just better off going on with that. We've got a JJ in the first slot here, which is that one, and we've got ruby tubes in all the rest of them. Right, let's plug in again. So we'll switch on. That's just the phone affecting it. Worse on this channel. Well, these wires here, these filament wires really ought to be on the outside of these ribbon cables, not tucked up inside them like that. But that's not appearing to show any problem. It's not the best place to have those, is it? Right, I'll flick it on standby, and we'll have that tube out. We'll replace it with the original one, and then we'll work our way down the line. Right, I've pulled these three tubes out, and I've just got the phase inverter in, and it's still humming. When you take the phase inverter out, the humming stops. But so it looks like something between the phase inverter and the output, so it's something like that. So it's just got all the feelings of no center tap on the filament windings to me. The way I don't know. Well, somebody's been in here rummaging around, and they've obviously not found it, and they've just scratched all that chassis. For whatever reason they've done that, I don't know. So if we look at these grounds here, we've got three of them, and there's this gunk, this red paint stuff, this gunk. So I'm going to get rid of that, and I'm going to clean these up for starters, and see if that cures our problem. One of these is these two, and I think it's this one. Now I don't know whether this is center tap for the secondaries or center tap for the filaments. Let's see what sort of rectifier. We've got a bridge. So we've got a bridge rectifier, so that means no center tap. So that must be for the filaments then, on that. So let's let's just get a meter. I'm on the current limiter, aren't I? That's why. So we are a bit, well, we shouldn't be that much down on voltage. This must be humming terrible then with that, because I got that on a 150 watt bulb. 3 volts. What we got on the other side? 3 volts. 6 volts. So yeah, so that's the centre tap. That brown wire is the centre tap then, definitely. So let's get all that off and clean it up. And before we start doing anything, let's just deal with that. Well, look at that mess there. So it's just a mess. So what I'm going to do, I'm going to pick those star washers off there and get some fresh ones. And the battery's getting a bit low on the camera now, so what I'm going to do is just clean all this up, clean these up. No need for all this daubing of red paint. I don't know what that's all about, but yeah, a mess. We'll clean it up. Right, you can see there I've cleaned those up, and you can see just how much they've scratched that now. Now I've cleaned all that off. That's really botched, that is, doing that instead of just taking them off and I've just had the wire brush on with the drill and just clean the chassis, make sure there's no I mean, there's still a bit of red stuff on the bolts, but there's nothing nothing untoward going on there. Check the output tubes. I've done some swaps, and it's not on the output tubes, but it is somewhere. So this preamp, the first 3 preamp tubes are out. Only the phase inverter is in now. You can see we've got that hum. But if I there, look. So I think it's somewhere on the board. I mean, somebody's been searching for this. They've been trying to find it, because you can see they've just been over everything and left all the mess. Yeah, and I know it's switched on, but yeah, it's there's something on this board somewhere. Check these ribbons. Doesn't appear to be the ribbons, so I'm just pushing on the preamp tube now, flexing that board. So it's something in that area, which is what I say, pulling out the preamp tubes pretty much. So we need to get this board out. You know, we keep flexing it, messing about. We need to get this board out and investigate what's going on the bottom of there. So I'm just going to pull that out. Right, let's just check that the voltage is going out of this before we start really delving in. We need to make sure that yeah, 14 volts and dropping, as you can see there. Right, so what we've got to do now is look at what it entails getting this board out. And they've put ribbon cables on either side of this, which is really pleasant of them. But while we've got this out, we're going to get these wires off here and put them around the outside of these ribbon cables. I don't think anyone's had this board out. What I think they've done is just soldered round everywhere, hoping to get lucky. That's what I'm thinking. And while I've got this main board out, I can have a look at this board here as well. That seems to make sense, doesn't it? Well, it does to me anyway. So we can have a look. So what we'll do is we'll take all the knobs off, because there's 4 ribbon cables, 5 ribbon cables on there. So we'll loosen that off. We've got one bolt, another one there, 2, another one there, 3, one there, 4. So at least 4 I can see at a glance there. We know we've got no voltage in it now, so yeah, looks like we'll just start stripping this down, and the Allen keys in the knobs. Right, I've got the board out. I've got, well, both boards, and I've just got it wedged up with this box here. It's something I used to do with these boards. I just wedge them up with cardboard because it doesn't mark or damage the traces. Use anything wood or metal. And quite frankly, so to say they've been stingy with the solder would be an understatement. So I've got bad soldering here, and it's going to be hard to actually get in and look close, but don't know how close we could get in. But if you look at those two there, you can see there's hardly any solder on those. So it's probably as well we've pulled this board out as well. And if we keep working our way across there, we'll go across, go there. Let's see. Well, oops, I don't know how close we'll get in with this, but we'll have a go. You can see that don't look very sparkling either there. Let's just find something to point it with, because yeah, there doesn't look great. And I better just try and put it on manual focus. I don't think it'll work on manual focus. It just never seems to focus. There we go. You can see it doesn't look very good there. So that's that. So we've got quite a bit of stuff to look at there. But if we look at this board here, and it's probably going to be hard for this to get down inside here and have a look. But somewhere I spotted there. Look at that. You see that? There. That's dry jointed as well. So it looks like we're in for a mass soldering session, because I only want to lift this board once. It's more like bird poo solder, because it's almost like they've been put in from the top, soldered from the top, because of this double print set out. So somewhere in this mass of capacitors, which is this whole block here, this whole area, this is where this fault is. So I'm going to have to get the 6x glasses on and have a real good look round. So it's going to be a nightmare. Oh, look at that. Oh, they're down at the bottom there. Can't see that, can you? See if we can get down there. I'll get that up. If we can get in focus. It's not to see that one there as well. So quite frankly, this for a new amp, this is shocking. It is I think it is anyway. I don't. It's not often I have a real go at things, and I try and see the best in stuff. And you know that if you watch this channel, but this is poor. It really is poor. This is what happens putting components in from the top, and it's why I don't do it. You know, this bird poo thing going on here. This is why I don't do that. A set of people do, and I'm sure this occur enough, but I just. And you see that one's not taken properly, and that's what happens. You get the odd one. That's why you're better off taking the board out, soldering them in properly. Maybe someone's had them out, I don't know. They've been soldered, so because there's flux all around them, so maybe it's not from the factory. Who knows? But that's just shocking. You know, take the board out and don't be lazy. I'm sorry, but if that offends people, then I'm sorry, but in this instance, there's just dry joints everywhere. All down, if we go down here, now if we move down onto here, all this is dry jointed, all down here, they're just rubbishy joints. So yeah, I've got some work to do here, and quite a lengthy process, because I could just go over it with the iron, put it down, and nobody'd be the wiser. But that's just not the way to do it. This crap solder that's on these, this ramel, has got to come off. People get upset when, you know, when I criticise topside repairs, but that's why. That's exactly why you cannot see what's going off under the board. It's always risky when you're doing it. Most of the time you get away with it and it's fine. Not in this instance. So we've had a good solder around, found quite a few dry joints. So we've soldered all those up. So what I'm going to do now is put this amp back together and just see if we've cured that problem. Right, let's switch on and see what we get. We've got the current limiter on, just in case, because we've had it'd be better if I plugged it in. Put the plug in the wall, but not the plug in here. The IEC. Yeah, just a flick of the bulbs, but nothing's not drawing any current. 150 milliamps on the wall. Let's see what we've got. Actually, I need to put that phase inverter tube in. Of course, I took that out, didn't I, to do the board. Let's just pop that in. Right, I've got that tube in. That may be because I've not got the nut on there. Well, we've got no hum. Let's go on to the other channel. Apart from when I touched that, but no. Right, let's get the other three tubes in then and see how we go. Because we're just back to having just the phase inverter tubing like we did before. I think we'll get all the nuts on now, and that's just the phone, the camera thing you can hear doing that. There's some gain on there. Let's get all the screws back in it now, because I only put so many in case I'd still got a problem with the board. I don't appear to have a problem with the board anymore, but it's noisy, so I just need to put everything back together so we're at least back to where we were before. Right, so been having a bit of a test round on the thing, and I'm sure this is something to do with filaments. The way those volume controls interact with it, you know, it's just seems to be. Now, I've had, as I say, I've had a bit of a test around. Just to be careful putting that on there. I don't want to damage it. So we've got some DC filament feed here. Got these couple of wires here coming in. Got a couple of fuses there, and 4 diodes. So we've got a bridge rectifier going on there. I don't know if you can see, because I don't want to shove this board back in, but basically they're here. You can just about see those there. Maybe not. Let's just go over and you can have a bit of a nose. Now, I've seen these diodes go funny on there. You can just about see them now. Seen these bridge rectifiers on the filament circuits go funny before. So we're going to start with those. We've obviously got some smoothing for it as well, so we'll check. So if the diodes are okay, then obviously we'll start looking at the smoothing. We might have to take these out of circuit to test them properly. I think they're 4007s. They look a bit odd. You can hear that noise. It's pink at the side of me, purring away. Well, I can't get to that one. There's gunk, all this silicone all over the place. There's just no need for it. When I fit these now, I've started just putting a fine layer around, just around the edge, and just sticking them on the bottoms, obviously, and just sticking them down, and they never move. You know, you don't need all of this. Oh, they've just gone. I mean, even on these, it's just everywhere. They've got it all over the drop-in resistors here. I don't know. It's just anyway, let's just fix it. Let's just try and fix it. So those diodes look a bit iffy. Let's just pop this back under. Those diodes look a bit iffy to me. So I'm going to start with those. I'm going to take those out, and we'll measure them out of circuit. It's the only way to be sure. And really what they should do with this is just put more heavy duty diodes in there. Whilst the voltage is low, the current draw obviously on a filament circuit is high. Although, so I measured the output tube filament voltage, and that's AC, so it must only be, we'll have to, it must be just the preamp tubes then that are on that DC, because let me just have a look again. So these are connected here. You can see at the bottom there, and this looks like the filament feed coming in. These two red ones there, that's the AC coming in for the B plus HT voltage. Yeah, I've got 4 preamp tubes here. So at 300 milliamps a go, that has been 1.2 amps. But that one's wired AC. So there's only 2 of them on the DC then, or even 1 of them, maybe just V1. Right, let's change those diodes anyway, because I'm just waffling here and looking. And then what we'll do is we'll just test and see which. Well, that one's definitely wired AC, and I'm guessing if that one is, then the phase inverter is. These 2, I'm not sure about. Sorry about that, just knocked the camera. Right, let's get these diodes out. Right, so if we just come in and we can have a look what's going on here. So I've had to take this cap out as I was trying to get that stuff off there without doing, and I've marked the board because it's just, you're trying to scrape this off and it gives way, and I've ended up marking the board slightly, and I hate doing that, so I'm even more annoyed now. So I've took this out because it's all stuck in there. It's just a mess, and you can see that this diode, I can't solder a new one in because it's just covered over with all this garbage. I have to say, I don't get angry very often when I'm working on amps, but I am getting a bit annoyed with this now because this is just unnecessary. It really is just unnecessary. We'll soften it up with some alcohol. In fact, we'll start with some of this for good measure. And I understand this, these amps none of these amps are made to repair. I understand all that. We've been through that on the channel many times. That and I've just accept that now. But this I don't accept. This just chucking this silicone all over the components. That's nothing to do with them not being repairable. That's just, well, I don't know what it is. You could forgive someone that's a hobbyist or something that doesn't, but these are manufacturers, they're supposed to know what they're doing. More so than I know what I'm doing. They're supposed to be, but so you can only put it down to not caring or whatever, I don't know. And this all takes time. It's costing the customer money. It is. If they hadn't have done this, we'd have had these diodes in by now, and we'd have had this amp running. Simple as that. It would have been up and running, and that's what makes you. And again, I've got these restorations going on, but then I get these amps regularly coming through the door. I get amps from the shop, and I think, oh, that'll only be a quick job. It's only, it's only a bit of noise. We'll soon track that down, and then it turns into another one of these poo shows like this. And you find yourself, having to, because if I go in at this hard and really start going at this silicone, I'm just going to damage this board. And this is, if you don't work on these and people think, well, why don't you just get the pliers in there and start out, then this board's, it's wafer thin. If I start hammering this board and I end up cracking it, well, then it's all over. And so just this, just throwing this stuff everywhere has made this job twice as hard as it would be. You see now, you see how I'm trying to pull that off. Look at the board bending, and say it's just wafer thin. The last one we looked at, the board was quite a bit thicker than this on that Hendrix 20, but this thing is seriously flimsy. By removing the capacitor, I've already removed above half of it, so that was the way to go. We'll soon find another cap to go in there. That's 100 at 100. I must have some of those. If not, we'll have to clean that one up, won't we? But I'm sure I've got those in stock. That was the thing really as well, you know, there were so many dry joints on this board. It was just like, it misleads you, because you think, well, we'll best sort all these got to be a dry joint. But yes, it was something in the back of my mind that it was filaments, and it's turned out to be right. Let's cut this up a bit more, rather than, and you see what I'm doing here, I'm cutting it up, I'm not scraping it off. Yeah, I still can't see the trace yet for the actual for the diode. It's still way buried under there. Right, I'll carry on with this, because I'm sure watching this is about as much fun as watching paint dry. And I'll return when I've cleaned it all off. Right, we've finally got all the leads and solder and crap out of those holes, and that took a considerable amount of time. If you get impatient with these boards, you'll damage them, because these traces these are double-sided boards, so those, it's not like you've just got a surface trace, you've got a trace that goes right through the board. And all that unleaded crappy solder that they use on these boards, it just will not come out of those holes even after you've got the pins out. So you just have to keep feeding it leaded solder and then removing it with the solder sucker, and then going back again, adding more until the hole will come clear eventually. And once it does, then you know where you are with it. But it takes a good time. You need a lot of patience. So one of the good things about this this board though is the components, you can see, are labelled on there. You can, if we look, the actual what components, the values is what I'm trying to say. So you can see here we've got 100 microfarad at 100 volts. So we've obviously got to put another cap in there, which is good, considering there's no schematics for these. Apparently I had a bit of a look online, and someone said they're being rather secretive about these amps. So another thing just to cover from the last video, had a comment from a guy who wasn't impressed with the humor that we had in the video, the gumption and all the pictures and things that, you know, the subliminal cuts and things that we have come up on there. And they said basically that it has no bearing on the actual video itself, and a lot of creators do it, and he really finishes the video. So it got me kind of wondering, you know, how people feel about the some of the humour that we have in the videos. So simple question is, do you want me to continue with it? I mean, I don't put it in every video, to be fair, but do you, as you are the watchers and you're the people that can't, you know, you are the channel, do you want me to continue with it, or do you want me to not continue with it? Just put in the comments a yes or a no, and that will give me an idea. Right, I've got to completely turn this amp around because I'm waffling now. So we're going to lift the board back up, solder in those components, and hopefully Bob's your grandma. Right, just been having a bit of a think about what's damaging these diodes. I was just looking at the smoothing here, 10,000 microfarad. So I glanced at that, just thought that was 1,000 microfarad. But then I started, and I've kind of looked at that while I was doing all this work. Just, you know, thinking which are the smoothing caps for this. But the way they've got the plastic on these is, the one is just over the side there. And I've just looked, and it's actually 10,000 microfarad each. So I've been off and had a bit of a read up. And these will cause a massive inrush current onto these diodes. Unless, of course, it's restricted on startup. And so I don't see anything in this circuit. All I see is these green wires here feeding AC across a couple of fuses to the diodes, to this, and then the wires go on to the, I may be wrong, there's some relays and stuff here, so I don't know what else is in the circuit. And again, we don't have a schematic, but that seems a bit high to me. And I'm in two minds whether to swap those for something like 3,300 microfarad. I mean, from what I can work out as well, only two of these, no more than two of these, possibly even only the first one, is, because I've not really massively gone through, and because I were looking for dry joints, didn't check the voltages. It were only when I took this to bits again, started testing around for components that weren't right, and those diodes didn't look right, and when I took them out, you know, a couple of them were blown. Two were okay, two were blown. But that to me just seems a hell of a lot of smoothing for two preamp tubes. I don't see anything in this circuit that warrants that amount of smoothing. So I don't know, but that to me seems high. So if any of you techs are watching, Jeff, Gooden, let me know in the comments. Anyone else? Right. Yes, that all sounds quiet, but for how long, I don't know. But anyway, so I've moved, let's just have a pointer. I've moved these wires away from underneath these now, pulled them over here out of the way. And the other thing that I've done as well is I've addressed these here. Took those crappy bolts out, and I've put some M4s through and some star washers and tightened those up and just made those look a lot better. Right, so we've got this bias setup thing, and the way this works, if I just tap that bit, you can see it says common in the middle, then you've got bias and bias, so that's for each tube. Basically, it's a 1 ohm resistor between the cathode of the tube and ground, and it measures on a scale of 1 to 1, so in other words 30 millivolts. You can see if you just tap at the bottom there, that will come into a bit more focus, or it should do. There we go. So you can see 30 millivolts is 30 milliamps, and there's a tiny, you need a tiny screwdriver, and there's a bias adjust here, and if we just look, ooh, that's very finicky, that is, my word. I mean, I only just putting that in there, put 5 mils on it, just turn that a tiny bit. However, only one bias preset. Now let's check the other one before we leave it, make sure the tubes are pretty well balanced, and they are very well balanced. The about 36 milliamps I've got on there. Let's go on to the other side, and that is at 240 volts, so that, yeah. So let's just see what the plate volt says. Now, I mean, you know, if you're not 100% on this, just set them at 30 milliamps. I've just biased this a little bit hotter to get a bit better sound out of it, and 35, it says 35 milliamps. We're a tiny bit over, but we'll check again. I've just checked to see if I turn the current limiter off, and I have. 453. So let's see what that gives us. 0.036 times 453. That gives us 16.3. So that's fine. It's only 0.3 more than what it was. So that'll do. 35 milliamps is the max you can go to. We're only a milliamp over there. and you can see it dropping. I mean, when the voltage drops to about 232, that'll be at 35, so that's perfectly acceptable. We've got a nice chunky power transformer. Got a nice chunky power transformer on it, so I'm sure it'd stand more than that. To be fair, I'm sure we could get that up to 70%, no problems, because that looks a beast of a transformer, and it's stone cold. And we have had this amp running for, albeit on and off, it's been running for a while, but that's pretty cool. Although we're not drawing as much current as we would be if we was playing through it. But yeah, that'll do for that. 36 milliamps will be good. 16.3. But there is one other thing to check before we go and fire it up properly in its case, and that is to check the fuses. Just to be on the safe side, we always check the fuses. So we'll check the oh. I think we're best to have a look at that, hadn't we? That looks a bit swagey to me. So we'll check what this fuse is. So it should be 1 amp, T1 amp slow blow, and it is indeed T1 amp. So that's probably been in from the factory. There we go. And the other fuse, the primary fuse, 2 amp slow blow. So let's take that out, and we'll check him on Bully's prize board, because I need to make sure that they are correct. Not that you can see them, because it's just switched on T2 amp indeed. So yeah, the fuses are all good. Right, thought we'd do an up close and personal on this one, seeing as it's a bit of an oddball amp and a new amp as well. We can have a look at the controls and things that we've got on here. Bright switches are very subtle, doesn't seem to make that much difference. Gets warmer as you turn the master in. So let's try the bright switch now. Yeah, that's better. So it's on the volume. country playing there. Some more reverb in. Nice. It's only a small tank as well. So yeah, not bad. Wind all the middle. Yeah, plenty of treble on there, even for the muddiest of guitars. Let's try the other channel. This thing is a bit of a beefy channel, plenty of bass on there, reverb. Shall we see if it's a bit of a metal beast? Let's wind the drive up. Let's give it full tilt, madam. Plenty of overdrive on that. Very toppy. Let's turn the bright switch off. That's a little better. 80s. Very rusty thrash metal there, very rusty indeed. Don't play much of that stuff anymore. Let's back it off a bit. I didn't quite have all the volume on the guitar either. That's tasty. Yeah, good levels of overdrive all the way down. Some amps start to sound a bit rubbishy when you turn the drive down, but this doesn't. That's quite impressive. American accent is terrible. Because I'm a limey. Very nice. That is a really tasty sounding amp. That sounds absolutely splendid. That overdrive channel is mint. That really is nice. Yes, that's right up there with the Egnate Tweaker. Another amp that we had that was really nice. That is a really top draw sound. Shame how it's been put together, but by gum, that does sound good. Wowee. Let's go back on this channel. The reverb's gorgeous on it. Get onto the neck pickup. Single coil. Put all that reverb in. That's gorgeous. That is a really tasty sounding amp. I mean, again, Celestion speaker in it, and these new Celestion speakers just sound phenomenal to me. But that sounds incredibly good. What an amp that is. You know, not great on the inside, but by gum, that's good on the outside. You can't argue with that for tone. That thing is awesome, and it's very versatile as well. Incredibly versatile amp. So there we go. Let's just pull the... There we go. We're all quiet. So that'll do it for this one. Finally. So thanks for watching, you all take care, I'll see you all in the next one. Bye bye for now.